Good morning and welcome to my talk, High Performance Serverless Java on AWS. Thank you that you are here so early in the morning. It's cool. So I think everybody is more or less Java developer, I hope. It's Java conference, but who of you has experience with AWS Cloud? Okay, many of you who has written serverless applications like Lambda API Gateway or something like this. Okay, several people. Okay, I think it's a good start. So because it's not talk about the basics, how to write Lambda function, but more or less how to optimize this Lambda functions to be just high performant on AWS serverless. So yeah, my name is Vadym, and I'm Ukrainian native, but I live in Germany since more than 20 years. I have these two passions, Java and serverless, especially on AWS. I'm one of the co-organizers of Java user group Bonn in Germany, where I basically live, and I'm AWS community builders in the serverless category, sharing kind of lots of experience, especially in that area. I started as a Java developer in the end of the last century, which kind of reveals how old I am. And yeah, we went through transformation with my company called AP Labs. We are basically creating and designing photo products like calendars, photo books, prints, everywhere where you can print the photo. And we had kind of monolithic Java application with Spring Boot and all that stuff. And then we migrated to the cloud, started at least 5 years ago and finished 2 or 3 years ago. And then we start to implement new things more or less serverlessly. And at least at that time, we found out that Java has had a difficult time because of the things I will be talking, how to adopt it. So we are also just did Node.js as a runtime just to keep up with all these requirements. But first of all, let's start with the Java popularity itself. So there are different sources, they measure it differently. There are job postings, GitHub repositories with Java code and all that stuff. So different ways to measure it, but anyway, it just doesn't matter where you look. The Java will be top 3 programming language. It's mainly about Java, JavaScript derivatives, and also Python. And I think it's justified, we love Java and so on, but if we will look into the life of Java serverless developer on AWS, basically managed runtime Lambda, how often it will be used. So first of all, what AWS offers is Amazon Corretto. This is more or less the derivative distribution of OpenJDK, like Adopt OpenJDK and so on, but Amazon invests heavily also in their own stuff. They also provide much longer support for Java 8. If you are stuck with that, as many companies, they provide it for good or bad until 2026. But basically now we are in relatively good world. Amazon Corretto only supports long-term versions. So the last one is 21 and the next one will be 25. And they support 21 since November last year. So basically 2 months after it has been released. If you look into when support for Java 17 was launched, it has been 6 months before. So April last year, so we needed to wait 1.5 years, and we were stuck basically with Java 11, which isn't good, but now AWS realizes and takes it seriously. So I also expect Java 25 will be kind of supported several months after this. So this is a proof that AWS takes Corretto and all these improvements I will be showing you, like Amazon SnapStart, really seriously. These are the people working for Amazon right now on that Corretto and all this optimization. Everybody should know James Gosling. I think Alexei Shipilev is also a well-known name. He worked for Oracle. He worked for Red Hat on this compile optimization and all this stuff. And other people, Volker Simonis, Roman Kenke, they are from Germany. So really power behind this, and there are many more. So they really take seriously because they recognize that this Java train may be going away and so on. So basically, Java is major and popular programming language. Framework support is really great. I mean, so many open source projects, Spring, Quarkus, and all that stuff. But if we look at the serverless adoption of Java, so on the runtime base, you see on the left, basically, these 2 studies of adoption. The one is the 3 years before and the second one last year. So basically, you see Java is still top 3, but the adoption increased from 4% maybe to 11%. And Python and JavaScript, Node.js managed runtime is far away from Java. And this is a bit sad story because so many brilliant Java developers, and I think serverless is a hot topic, or event-driven architectures, depending how you would like to see. And Java is way behind in this serverless adoption in AWS. And I will argue on the other cloud providers, it could be the same. Yeah, there are some basic problems with that. And what are those problems? If we would like to use Java, and we as a company would have used also Java with Lambda several years ago if it was possible. But the thing is, this cold starts, especially cold starts, is something that can be quite extensive. We will be seeing that. Many say, okay, why, yeah, there's several seconds cold start time. So many applications are synchronous and it just doesn't matter. But I have never seen application which does login in the asynchronous way. Yeah, you cannot say, yeah, proceed, even if you are not logged in, I will check later. The same is payment and all that stuff. There are some derivatives with asynchronous workflows, but many requests, many public-facing requests needs to be synchronous. And you know the studies that waiting for the response for more than 1 second can result in dropouts of the users, basically. And we'll be seeing what are the cold starts with Java without any optimization. Maybe some memory footprints can cause a high cost on AWS, just it's only relative. So let's dive into this cold start, and especially in this world of Lambda. So Lambda is a container, and it's only one container is capable of executing one request, so one request in the time. And then the container cannot execute many, like we know from Tomcat and all other web servers. So the container is there to execute only one request, or execute one business logic of particular Lambda function. And if we were thinking of these containers, so first of all, the life cycle of those containers, when we need a new container, for example, completely new container needs to be started, the environment even, I would say, the new environment. So first of all, we write new Lambda function or just update the code of the existing one. So then we need a new environment here. Yeah, if the Lambda function is finished, the environment, so the whole execution environment will be back, like connection pooling. Yeah, this is the pool of warm containers. So when we need another one if we, for example, there are not enough containers. We have 5 requests, but only 4 warm containers. So we need to spin another one. Another use case is, for example, if AWS recycles containers, and they recycle it from time to time, they don't publish exactly when. Yeah, it can happen after several minutes or several hours. The reason is just to patch the operating system about the security, so that even the warm container that will be used will not stay forever. So now let's look into the Lambda life cycle and see what this cold start is and so on. So you see here this download your code, start execution, init code, execute handler, and these 4 phases. And the first 3 are cold starts. So what's happening with if we start the new environment? So the new environment is Firecracker VM. This is the own solution of AWS. It's not Kubernetes, but this is similar container management, more or less. So Lambda, then AWS Lambda starts the Java runtime because we are using Java for our use cases. This is the second step. This is start execution the environment. And then the static initializer block of the Lambda function will be kind of executed. This load the class itself, all dependencies execute the static initializer block, so everything outside the Lambda function itself. It can also do just-in-time compilation, all this stuff. So these 3 phases are these cold starts. And what's important is, this is init phase, you have the full CPU access for free for 10 seconds for managed Java runtimes, for 21 and so on. For example, for Docker Node, it's not a managed runtime in that sense. And this is important. We will understand also later why. Because, so first of all, the 4th step is the execution of Lambda function itself. So this is the code within the Lambda function. And this is if the container will be reused, you only have the warm start or normal execution. If I say a warm start, it's the normal execution of the Lambda function. If you can reuse container, you only have this warm start. If there are no containers, you need more containers, so you adjust it and wrote the new function, you need new container, and it will go then through all these phases. So what's important, if you write Lambda function, it just doesn't depend on the language, you give the Lambda function memory setting. And you don't give the CPUs. And the CPU is adjusted according to the memory. So if you double the memory, you will double the CPU cycles, and you will get access to the one full CPU with a roughly 2 gigabytes of memory. Why is it important? Is it because if you have, and once again, you have in the init phase, full CPU always for 10 seconds for free. And if you have, for example, your normal Lambda function with half of the gig memory, then in the Lambda function itself, you only will have the quarter of the CPU, but in the init time, you have the full CPU access. So you can speed up things, and we will see the examples of that. So now let's look at the demo application. We have something similar at our work. So you have API gateway, you have Lambda functions behind this. This is the application, very simplified view in our application to create, delete products, retrieve products by ID, and we save it in the DynamoDB. So we will start with measuring all that stuff, giving Lambda function 1 gigabyte of memory. This is something kind of standard. You cannot do too much wrong with that. We will also use default HTTP client for DynamoDB connection. Yeah, so if you talk to DynamoDB, it's a HTTP client. And if you don't set anything, it's then Apache. The artifact size of that is 15 megabytes if we will deploy, just for information. We can also tune Java compilation options, and we will start with what was perceived as a default. And this is just the default in Java is tiered compilation, but we will deactivate it and stop at level 1 C1 compilation. So the experiments where I run the experiment for 1 hour, I reproduced a bit more than 100 cold starts and more than 100 warm starts with that. So you see that image is for cold start and this is for warm start. So you see basically you have roughly 1% of the cold starts in the, more or less in the, how it just distributes, because otherwise you have containers there that can be reused, but 1% of the cases will be cold start. So now let's see what will be the results. So first of all, look in the first row, it's a cold start, and just you see this is percentiles. So in case of P50, so 50% of the requests has been finished with 3,000 milliseconds, something like this. This all are millisecond values. And what you see, these cold starts are significant. Yeah, P50 is not representable because it's only half of the request, but P90 is more or less representable. In 90% of cases, you have 3.3 seconds of the cold start. And it's a big one. And you also see the warm start. So the execution of the function itself is quite quick. So Java is a very performant programming language, so this is negligible. In case of P90, you have 7 milliseconds for Lambda function to retrieve something from the DynamoDB. Yeah? Remember, this value is just max, and we will be talking about why it happens that we have that max value that is so big. So now let's talk about, that will be the options that we will be talking to reduce the cold start time. So we will be talking about general best practices. We will introduce AWS SnapStart. It's AWS own technology. We will be talking a bit about how just to proceed with GraalVM native image, and I think that we will cover that. So best practices, as we can speed up things basically in the static initializer block. Yeah, in having one CPU, in most cases, this is more than your function will have for 10 seconds, even for free. We should put, that's general best practice in Java anyway, everything in the static initializer block which can be reused. And in our case, it's, for example, creating DynamoDB client. It can be something else if you are using, I don't know, SQS, you will have SQS client. So this is that belongs in the static initializer block, and not in the creation of, not in the function itself, because why you should recreate this with each invocation. And the second best practice is just to set the region where you are deploying. So basically, you know where you are deploying. It's normally one region. In our case, it's Frankfurt, you central one. You can leave it empty. AWS will figure out here where you will be deploying anyway, but it will take maybe 100 milliseconds additionally. So just put it there. So this optimization, it's ugly, but we will hugely benefit from this later. So the name of this is priming, and priming is more or less faking some invocation when you know that it can be expensive. And for example, if we will ask DynamoDB, in this case I'm asking, give me the item with ID 0, what will happen is that client needs to be initialized, but also the Jackson marshaller, which is used for converting objects in Java to JSON or other way around, it needs several hundred milliseconds to be initialized. And it's only one time for the life cycle of the function. So this requires knowledge how the things work behind, but in this case, you can speed up putting the whole fake invocation just into the static initializer block. This makes the code ugly because you don't know the ID of the product, more or less. Yeah, you need to do some fake call. It's not about returning the result, but it's about initializing Jackson marshaller and loading the classes that are involved in all that stuff. If you put it in the static initializer block, it's an ugly code, but you can speed up things. So this is the technique, and we'll be heavily using it later, called priming. Yeah, it's up to you. Sometimes you don't have anything to prime in normal hello world, so what would you prime there? But in case you know, and it requires some knowledge and understanding of the things behind, you can do that. Additional ugly code. And with that, now the meaning of this value will be clear, because I did not prime that. And with the first, in case I have call start, the warm start also took more, because this Jackson marshaller needed to be initialized once. Yeah, I didn't prime that, and this is the things, and also the classes that haven't been loaded within static initializer block were loaded. So this is max value. Practically, it corresponds to the call start. So if I will prime this, then the call starts will be a bit less than that, but you need to add this as well. So you will be more or less with 5 seconds call start time in that situation even. And this is something that you need to know, that in case if priming is possible, but not done, and call start happens, the warm start will also take longer. You need to think about that. Would you like to prime or not? But basically, Java normal code start time will be 5 seconds with that kind of application without more or less any optimizations. So basically, what you need to avoid is all that stuff that we like from normal dependency ingestion frameworks like reflection, runtime bytecode generation, and all that stuff that requires simply time during the initialization, because that increases the call start time. For example, if you will use Spring Boot application without cloud native, without native image and so on, the call start time may go up to 10 seconds because of this annotation processing and all that stuff. But it's the subject of another talk. So now let's deal with how to optimize this, because it's just not normal. 5 seconds, not everybody, even if it's only 1% of the request, 5 seconds, it's not normal. Yeah, the call start of Node.js or Python will be something around half of the second. And here we have 10x. Like, it's just not acceptable. So I wrote the blog article series about call starts a lot on the dev2, where I'm just blogging as AWS community builder, and measured a lot that I will be also presenting now. So I just simply reference that. But basically, what's the SnapStart? SnapStart adds the idea of Firecracker microVM. This is the environment, the whole environment, all execution environment, create and restore snapshot. Yeah, so the snapshot of the whole environment will be taken. But this is divided in 2 phases. So the first phase here is the deployment phase, when you deploy your Lambda function, initially or after the change. So what will happen there, and you can activate, we will see SnapStart on the Lambda function base. It's up to you to do it or not. It's now always recommendable, more or less, but you can do this. If you activated this, what will happen, it will not only be the deployment of the function, but also the static initializer block of the function will be called. So basically, the call start phase will be executed additionally during the deployment phase. So, and then the snapshot will be taken. Yeah, and also there are hooks. We'll be talking about this. Just ignore them for several seconds. And during the invocation phase, this snapshot will be restored in case SnapStart is enabled. There is also after hook. Let's forget it. Only then the application, so the invoke of the function will happen. So what's the idea behind it? So why it could be important? So the idea is, of course, that the restore of the snapshot takes less time than the normal cold start. Otherwise, it's just why you will be doing this. Yeah, and we'll be checking after this, is that true or not? So this is the idea, and this is a bit more information how this Firecracker snapshot is more or less stored. It's taken, and then it's stored on S3 with the tiered cache. This is tiered cache, remember, something like Docker layered caching. Yeah, it's stored in different availability zones, like a cache, and then these parts are expired. Very cool technique. I will show you the reference to understand more. So who of you know CRaC and CRaC? These are very known in the Java world, at least as names. Please raise your hand if you at least heard about the concepts. So I just would like just to bit kind of explain what are the differences. Basically, CRaC, this is the technology is available since 12 years, more or less, just to move containers around. Yeah, this is the Linux technology. Basically, that's it, just that you can snapshot also and move containers around. So what's the difference between Firecracker, microVM, and CRaC? This is that the CRaC only saves a single process. But the Firecracker VM and SnapStart uses Firecracker VM does more. It saves snapshots the whole running operating system. Yeah, everything. It has advantages. You don't need to deal with file handles and all that stuff because it will be there after the resume. But there are drawbacks. Yeah, you need to reset this def random and to sync the system clock and all that stuff. And there are other challenges like time-based caches. So what if you snapshot the cache which is valid for 10 hours and then restore it after 11? So the values are not there. So you don't. So there are things that you cannot use with the snapshotting, or just it's your danger, more or less, to do this. So Firecracker does more. It just doesn't relate to CRaC, but the concepts are more or less similar. So that's once again, basically, on the Lambda function, go into the configuration and configure public versions. Configure SnapStart. It's simply kind of checkbox, and then it's there. If you do this, and then deploy your Lambda function, you will be seeing something that the static initializer block has been invoked, and then basically the snapshot will be taken. If the function will be executed with the SnapStart enabled, you will see something like restore report. So the snapshot has been restored. If you don't have SnapStart, you won't see this. This is kind of the proof in the log files that this has happened. So now, once again, you saw these hooks here. These are optional hooks before snapshot, before creating snapshot and after restoring snapshots. And they implement CRaC API. But they only implement API. There is no CRaC implementation here. They only more or less took the API. And probably you know CRaC. The talk is not about CRaC because SnapStart doesn't use it, but the CRaC's idea is just to snapshot and restore GVM itself, and it's based on CRaC. Yeah, this is a separate project. Here is Gerrit Grunwald. I have seen him also from Germany working for Azul, who are pushing this, but this is the whole parallel technology. But the idea is the same, that the restore of GVM is so quick that the time to the first operation, you see here blue, will be quick. So, but basically, SnapStart is only using the API. What does it mean? You simply import this org CRaC as a dependency, whatever you use. You implement the resource interface from CRaC. This interface gives you basically two methods. This is you need to register your file for API or the class. This is more or less to copy the same string. Then you have before checkpoint and after restore hooks. After restore hook is basically empty. I don't see a lot of use cases. The interesting part is before checkpoint, and it's once again it's invoked in the deployment phase before the snapshot is created. And what you can do there, remember our priming. Yeah, if we can speed up things, we can do it here in this before checkpoint. So basically, I am priming this DynamoDB invocation. This is in the deployment phase. So, and with that, it just doesn't take time of the execution phase. And this is important. So deployment phase will take per milliseconds longer, but you will see what effect does it have. So basically, you don't need to call the DynamoDB table by ID. You can also ask for metadata of one table. It's the same. It's just only to kick in this Jackson marshaller. So there is a guide from AWS itself, SnapStart priming guide, so you can read when it's worth doing, when it's not. We need to understand just it's worth doing or not. This is the recommendation of the talk by Mike Danilov, who works for AWS Lambda under the hood. There is an article in his talk on the GeeCON, which basically goes deep how this piece of technology is implemented. And it's really, really cool what AWS did. So simply, if you would like to dive deeper, then that's the right place, because my talk is more general and it's not only about SnapStart. Of course, SnapStart has its challenges and limitation. AWS advertises this technology language agnostic, so there is no Java. But currently, SnapStart only supports Java managed versions of Lambda. So there is nothing else. I think it will make sense for net environment. They suffer from the same problems, but currently it's only Java and nothing else. SnapStart adds up to 2.5 minutes additional deployment time, because taking the snapshot and then places into the TR cache in many availability zones of the region takes time. So that's the price, developer experience. 2.5 minutes per Lambda function. If you deploy multiple, then this snapshot will be taken in parallel. So it only adds a bit. Yeah, so basically you can ignore this, but 2.5 minutes, as I measured this 1.5 years ago, it has been 3 minutes. So I expect here optimizations. Also, there are some problems if Lambda function wasn't invoked for 14 days. If you have staging on something else, then the snapshots will be deleted. It costs time, storage space, and AWS deletes that, and then you run into the error. If you then call the function, and then snapshot will be created once again behind the wall, kind of, but it takes 2.5 minutes, and it's not optimal implementation. But I don't assume that you have too many functions that are not invoked for 2 weeks. And in case you're using staging, maybe you don't need SnapStart at all. So SnapStart also doesn't support several things like provision concurrency in AWS. It doesn't support ARM architectures, only x86. I don't use ARM. It's not a problem for me. You cannot attach NFS system like Amazon Elastic File System there. You can only attach S3. For me, it's enough. But sometimes you need NFS-based system. Just you cannot activate SnapStart. And there are some limitations of the temporal storage, but it's not wild. But this is generally, there are things that you need to know. So basically, let's look into the measurements. So now we have 3 measurements, and what we will see here, now you see here, this is without SnapStart. This is basically what I showed you with these 3.5 seconds, more or less. The second measurement is I enable SnapStart, but I don't do priming intentionally. And the second one is with priming, this DynamoDB priming, just calling get item by ID. Yeah, the same stuff, 1 GB memory, default Apache HTTP client, and this tiered compilation option. Disabled and stop at level 1. Okay. So what you see here, only by enabling priming, which is checkbox on the Lambda function, you reduce the call starts by 1.5 seconds, more or less. From 3.5, you go to somewhere 2 seconds. If you use priming, and sometimes you don't have something to prime, but if you use that, you see here P90, you will go, the call start is a bit more than 1 second. Yeah, so from basically 3.5 plus this max value, this is something that it's really worth knowing that you can go up to 1 second. It's not half of the second like Python or JavaScript, but it's really huge decrease only for some checkbox. Now let's look into the warm start, so the execution of the function itself. Does it have any effect? So you see basically, yeah, SnapStart is more for reducing call start, so you don't have any huge effect on at least this until P99. Yeah, so all values without SnapStart with are similar. What's interesting there, the high P99 and max values, you see that this with priming, the warm execution is very quick also because we already primed everything. So we need just this without priming, you have these additional max values that go high for loading the classes, for loading Jackson Marshall. This is, in this case, it has been done when the snapshot is created, before the snapshot creating, during the deployment phase. And that's why the warm execution, the invocation itself is really quick. So now let's go deeper. So now let's experiment. We started with 1 gigabyte of memory. Let's just test if we assign between 256 megabyte until 2 gigabytes. This is the values for without SnapStart. So you see additional memory, it's worth doing. So if you have only a quarter of the gigabyte, the cold starts are not acceptable. But it's also about pricing. So the more memory, it can cost you more, depending on the execution time. But you see the sweet spot is somewhere with 1 gigabyte. Adding more memory will not reduce the cold start without SnapStart. The warm start, the same. Without SnapStart, you see basically around 1 gigabyte. You have more or less than the same values. More or less the same will be if we have SnapStart without priming. You see also memory matters, and with somewhere around 1 gigabyte, you have also sweet spot with SnapStart without priming, and the same for cold start and for warm start. So basically, all these results are similar. The 1 gigabyte of memory for that kind of use case seems to be acceptable, and this is with SnapStart and priming. You see the values are really close to each other. So the memory doesn't play a huge role here. Yeah, you see, you can maybe have 668 megabyte of memory assigned with SnapStart and priming. Yeah, and less memory, it will cost you less. And the warm starts are also very close here if you have SnapStart with priming. So basically, with SnapStart enabled, and if you have priming, maybe you can assign a bit less memory and you will be also good to go. So another experiments that I did was the artifact size. It's known that if you have less size of the artifact, the deployment package of the Lambda, then the cold starts will be less. You need to download less from S3, and probably more code means more instantiation. It was clear, but what happens if we have priming? Yeah, SnapStart and priming, where we basically did a snapshot. Is the restore time also kind of depends from the artifact size? That was what I wanted to investigate, to see that I had three packages. The small one is Hello World. Nobody writes this small application. The medium is our application, and big one, I just added some dependencies which I didn't use until 50 megabytes, and then did a snapshot. What you see, yes, and it's also true with SnapStart and priming, that the yellow application has bigger cold starts. Yeah, so the package size matters a lot also in case of SnapStart, and this means that you only need to add the dependencies that you are really using. Yeah, so this is true anyway, but if we use web applications, we pack stuff that it's not used because it starts once and runs, but here it matters a lot. So just only put the dependency that you use, see what is only required in the compile time, like JUnit, all these test libraries. Just don't put them because it will bite you in the end, and it will simply impact the user behavior. So now let's experiment a bit with Java compilation. You probably know how it works. We are in the Java conference. Basically, you can change the compilation options. There is Lambda function here, environment variables, and you can provide this Java tool options, and you can set whatever you want. So basically, the default one is tiered. This is the best of breeds between client C1 and server C2 compilation, but you can set different levels. You can deactivate tiered application and set stop at level 1. This is for compile client compilation without profiling, stop at level 2 with some basic profiling. There is a full profiling level 3, and the fourth one is C2, this is the server compilation. Yeah, and what's the idea here? Why we need to experiment with that is that sometimes this optimization, like profiling and all this, the full optimization C2, they kicks in after 10,000 invocation of the function. For example, the optimization. This is the default value. The thing is, there is no guarantee that one Lambda function will be executed 10,000 times before the container will be recycled. So you maybe do some optimization, pay for this kind of compilation, and that needs threads to compile the Java behind the scenes, so it steals performance from the application, but it just doesn't provide you any benefit because the Lambda function, the whole container may be recycled. So it's worth experimenting in this short-living Lambda function, what will be the best option. And before priming, the people experimented and said that you should basically disable tiered configuration and stop at level 1. That will provide you the best world between cold and warm start. Just not too much optimization because it will steal the time and steal CPU time and all that stuff. But it was before SnapStart, and I wanted to check out what we will have with that. And this is only P90. Yeah, just I ignored everything else. It's representative, and you see here tiered, stop at level 1, stop at level 2, stop at level 3, and so on. These are the cold starts. So what we see here, that the sweet spot is indeed between somewhere tiered application, a tiered compilation, and stop at level 1. Yeah, this green one. Yeah, so the server compilation C2 is the worst possible solution for Lambda. Yeah, which is sometimes was the best for the server world. You see these green ones, you have the biggest cold start. With SnapStart enabled and priming, it's close, but otherwise. So this red ones, tiered compilation, and this green one, stop at level 1, they provide the best things for Java 21 for cold starts, and even. But if you will see the warm start, it's basically the same. But here is this stop at level 1 is a bit better one. Here we saw that, for example, tiered compilation for cold start was outperforming a bit. But for the warm start, it's other way around. Stop at level 1 is a bit more performant. But you see, we're talking about several milliseconds here, from 8 until 12. So it's close, and then it's up to you what to decide, what you would like to optimize, bit lower cold starts or bit lower warm starts. So you have options, but basically what's true is that stop at level 3 and 4, just ignore this, and even stop at level 2. They don't provide this good results. So it's basically the choice between default tiered compilation, so you don't need any parameters, and stop at level 1. So I also tested the impact of HTTP clients. Yeah, so if you don't do and instantiate this like this DynamoDB client, then the default HTTP client will be Apache. Yeah, this is documented, but you have two other choices. You can set programmatic URL connection. This is also that comes with the Java. And AWS released its own client, HTTP client, optimized for short-lived Lambda functions. They did it last year, and it has synchronous and asynchronous variants. So let's look first. These three options are for synchronous ones. Yeah, so you basically can construct it and then put the right dependency, in this case, that one, or you can put URL connection. And I wanted to find out what will be the best results with all those three. This is the cold start, and basically you see that AWS own CRT client, this more or less outperforms all others. And with Apache, it's a green one, you have the second best result, but they are relatively close, especially with priming. And for the warm start, you have basically the same. So this green one's Apache, and Amazon one is a bit better. So this client is really cool. Yeah, with this priming, the results are really close, but your URL connection client seems to produce the worst result. Of course, there are also asynchronous clients. If you would like to develop asynchronously, it's only for that use case. Yeah, it's just a different story, because then you probably need to also the front-end technology that can just stream the results. But then if you would like, you can create DynamoDB async client, and then HTTP client that you will be giving there should be asynchronous one. And AWS offers here two possibilities. The default one is native new without doing something, and there is this AWS own CRT async client. the same story. Then if you will use this assume client, then the result of the invocation will be completable future. Yeah, not the result itself, but the completable future. You can join it or stream it to the front end. So you will have the asynchronous programming model, and it's then up to you to use it or not. You will then need to provide the right dependency. And with that, with the two choices, you see the green one, AWS own one, outperforms completely the native Neo. Yeah, for the cold start and for the warm start as well. These green ones are lower. Yeah, so this is another piece of AWS technology in addition to SnapStart with that HTTP client optimized for short-lived invocation, which are good, which is really good. But of course, there are recommendations also by AWS when you should use what client, because you can tune more with Apache client, caching, connection behavior. You can tune less with AWS CRT. Yeah, I only tested with defaults. I didn't tune anything, but there is additional potential when you know what you are doing. That's very important. Nevertheless, but so there is kind of the potential. If you have choice, this is something good. So now let's talk briefly about GraalVM. There will be lots of talks. I think Alina Yurenko works for Oracle, also from Ukraine, will be talking about that tomorrow. So everybody probably knows what is this. And we are all basically interested in this GraalVM compiler, yeah, which gives us ahead of time compilation. Yeah, and ahead of time, everybody knows you just package everything together in the compile time, what should be reachable, all classes, methods, fields, and everything, and then you compile it to the native code. Yeah, GraalVM supports Mac, Windows, and Linux, and basically gives you the choice between just-in-time compiler and AOT compilation, but for serverless application, it's ahead of time compilation is really valuable because it optimizes for startup speed, low memory, and small packaging, which is what the serverless is all about, basically. And it promises you also to reduce call times, but also memory footprint, which is also important because it's the cost factor. The situation is AWS Lambda doesn't support any managed GraalVM. You don't see that. You just manage Java, but GraalVM is just another runtime. So how to proceed with that? AWS offers the custom runtime option. You can deploy custom runtime. You selected it, custom runtime, and with that, there is a format. This is a zip file, and the zip file, as one of the example, should contain the file with the name Bootstrap. And this Bootstrap can be the GraalVM native image. It will recognize and load this image. Yeah, so simply provide this GraalVM native image, name it to the Bootstrap, package the function as a zip, and then you are done. The situation is custom runtime only supports Linux. It's the Linux system, only Linux native images. So you need Linux for that. Yeah, release calendar now, GraalVM changes this. They release also every 6 months, not only long-term versions. So they try to just for each Oracle GDK version will be GraalVM. So you can enjoy newer Java versions if you would like. You can now take 22. Yeah, and also now there is no enterprise version, which gave a bit more performance. It's also now free within OpenGDK, which is also good. So now let's look into the results. The same 1 GB memory Apache client, but now I added GraalVM native image to this for my sample application. You see here, of course, very close to each other, all these P's for cold starts, and they are around half of the second. So what we can do here with SnapStart was basically P90 1 second. Here can go down to half of the second. Yeah, and sometimes you don't have priming options, so you will be staying here. For the warm start, this is P99 only until you see also very, very close. So warm starts are not getting worse with GraalVM native image. They are comparable, and even the highest P99 and max values are even better as all other options. So GraalVM native image reduces this even further. Yeah, just that's what you see. And I also experimented with memory settings for GraalVM native image. I just want to find out, is that 1 GB the right spot? And I just tried 1/4 gigabyte until 1.5 GB. And what you see for the cold starts, that the values 0.5 GB, 768 MB, 1 GB, very, very close. Yeah, so you can select even less memory. Yeah, pay less and have comparable cold start times. The same is also true for the warm start. These values are really close here with that area. So you can decide for 768 or even for 512. It's only 14 milliseconds here, 13 milliseconds. So really very close results. And these are the highest P for warm start, P99 and max values. You also see the values are really close. And this leads to the conclusion that basically with GraalVM, you indeed can use less memory and pay less then also. But of course, there is also a but. Yeah? Of course, GraalVM is really powerful. It just without any doubt. And if you optimize for the lowest possible cold start, it's for sure the right choice. But it has also its challenges. It's free in terms you don't pay for this. But for example, you need Linux executable, so the people with Windows, they need to build somewhere else. And the situation is, it's up on you to scale. It's your responsibility, CI/CD of those native images. You can, of course, use managed services and all that stuff. But to build one image, you need probably 10 gigabytes of memory. And you need the hardware, and if you build multiple Lambda functions in parallel, you need to think about scaling CI/CD, or managed service will do it for certain price, so it adds price on this, adds CI/CD work that needs to be done on your side. SnapStart is only option, and the whole snapshotting is managed for you. Yeah, with a higher cold start. Build time is a factor. I have the same between 2 and 3 seconds to build GraalVM native image on more or less powerful hardware. Of course, with more powerful hardware, it will take less, but it will cost you for the hardware. So there is kind of the trade-off here, and this initialization phase is, this 10 seconds is not free because it's not managed runtime. Custom runtime is not a managed runtime, so you will add also a bit of costs. Of course, you need to pay attention to other things, like reflection. Yeah, so ahead of time compilation means you need to package everything together that you will need. But there is a whole lot of reflections involved if you invoke Lambda function. Yeah, and then you need to more or less to have this JSON file giving these files, the class names that needs to be packaged because they will be called by reflection. These are all your Lambda functions you need to give because they will be instantiated. There will be some cloud formation or some template that will be passed, and then this Lambda function will be instantiated. You need all your entity objects. They will be converted from JSON, yeah, with the reflection. And you need some, if you use API gateway. So you need to think about, because otherwise you will have runtime errors. You will then it's just back and forth. But if you did it several times, you basically know what to do. Also, GraalVM has the page where you see kind of, we are using a lot of open source, and we would like to be sure that these open source libraries are GraalVM ready. There will be no effects of reflection on class not found and all that stuff. So GraalVM publishes the frameworks that are kind of battle tested. This is Micronaut, Spring, Helidon, Quarkus, and they also publish the list of open source projects that they have tested in certain versions. Yeah, but sometimes you would like to use or historically use something that cannot work currently with GraalVM, and it can be prohibiting. So this is basically, I don't want to jump there, but so we only spoke a bit about Lambda connecting to DynamoDB, but there are other choices. Like there is serverless relational database, Aurora version 2, that you can use with Data API in AWS. Data API gives you the possibility to connect to a relational database over the HTTP like DynamoDB. Without this connection pooling GDBC, there is this option that you don't manage connections, which is difficult with Lambda. I currently in the middle of publishing the article series that was the part 6, how to deal with that, and I also measured the cold starts there, so in case you don't use Lambda, you don't use DynamoDB but Aurora Serverless, you can read about this. I'm currently also in the part 5 of how you can run Spring Boot 3 application AWS Lambda without changes, because many people have Spring Boot, they are very productive, and they don't want to use plain Lambda but migrate. So I will be discussing different strategies. Currently, I'm writing about Lambda web adapter, and I have also written 3 parts about serverless Java container. There will be Spring Cloud functions, Docker image with Spring Boot, and also GraalVM native image. So there will be links. So if you would like to follow me on Dev2, I will just experiment and, of course, also give separate talk about this. So we are now in the end. But basically, would like to know what should I use from this, at least SnapStart and GraalVM native image. I personally would say if you can prime something, start with something simple like SnapStart. It gives you 1 second of cold start comparing to half of the second, but it's only checkbox. It's quite easy as dealing with all GraalVM native image. If you have very business critical application, of course, use GraalVM native image or you don't have something to prime. Yeah, then you will have 2 seconds of cold start time. It might not be acceptable. But I personally prefer to start as much as possible with that more or less managed kind of thing. And SnapStart is, for me, more managed in that sense. So I hope there is nobody from Oracle working here which says GraalVM always. Really cool technology. And I personally thought that AWS will provide managed GraalVM. Maybe they will do sometimes just later to provide you options, but they did their own way with SnapStart. With that, I would say thank you, and I would personally like to switch to Slido and see, probably, yeah, you see the questions. AWS Lambda finished native support to Go. Why did you do that? Do you have any opinion about it? You mean native support to Go as a programming language? Who asked that question? Or what is to? I personally am not a Go guy, so I cannot say anything about this, to be honest. Running the code while deploying phase isn't of a hack. What do you have any opinions? Will the AWS remove this suddenly? So the code will not be run when you have deployment phase. So there are situations, if this is the new function, it will be only published when this snapshot is taken. Yeah? Otherwise, the function is not available. If you have the existing function and you're releasing the new function, and then this new snapshot will be taken, as long as the snapshot is not taken, the old version of the Lambda function is still available. So you will not run into the errors. Yeah, so of course it takes 2 minutes for the newer function to be kind of invocable, but that's okay, I think. Yeah, so you deploy the whole application, the whole stack, and only when everything is deployed, then the application is ready to answer.
Thank you.
Yeah, thank you very much for coming. I hope it was interesting. Yeah. And have a nice rest day of the conference and also tomorrow.
Thank you.
Thank you.